This is my mathematics solar panel installation assessment. This is part of assessment 2 of mathematics in the primary classroom. This MyMat highlights some of the aspects which we need to consider with the installation of solar. Some of these are what system would be suitable for 2 adults and 3 children, the number of panels required, annual bill of grid-only power, roof space required, kilowatts, installation and maintenance costs, annual bills, adding and subtraction, what angle is best for the solar panel installation, standalone systems, savings, comparisons, ecological footprints. This is our plan. We want to install solar to cover all of the electricity used. We need to consider what size system we will require, the cost to install these panels, and how many years until the cost of the system has outweighed the savings. The information that we need is the average electricity cost per family for an average family, how much on average a family uses in power, and how many watts does one solar panel produce. An average family spends $43 a week on electricity. So we get this $43, we multiply it by 52 weeks per year, and this will give us $2,236. So our total yearly electricity cost is $2,036. How much does one average family use per year in electricity? According to Origin Energy, householders use 8,030 kilowatt hours per year. Now, the largest solar panel on the market produces 250 watts per day. Here are some divisions to help us work out how many solar panels we need. Daily kilowatt usage is worked out by 8,030 kilowatt hours per year divided by 365 days. This will give us 22 kilowatt hours. Kilowatt system required would be 22 kilowatt hours divided by 7, which is our average daylight hours, and this is 3.14. Kilowatts per panels, 250 watts is the largest panel on the market. This is divided by 1000, this will give us 0.25 kilowatts. Panels required, 3.14 divided by 0.25 kilowatts. This equals 12.56 panels, rounded up, will be 13 panels. How much does it cost to install 13 panels? Well, according to True Value Solar 2015, this will cost us $4,799 to install 13 panels. How many years until the initial outlay has paid for itself? Well, we established that the installation cost was $4,799. We divide this by $2,236. This was the annual on-grid electricity bill. This will give us 2.15 years, which is rounded up because the actual figure is 2.14624. Our environmental footprint. This household requires 8,030 kilowatt hours per year to operate. If we look into the amount of coal required to make this happen, our mathematical problem would look like this. It takes 0.476 kilos of coal to produce 1 kilowatt, and this is according to the US Energy Information Administration. So our mathematics problem would look like this: 8,030 kilowatt hours times 0.476, which gives us 3,822 kilos of coal which was burnt. This is our environmental footprint continued with the installation of solar. This coal can stay on the ground and not be burnt. This proves that our carbon footprint can be reduced with the installation of solar. Here's how we check our answers. Working backwards using multiplication on slide 8. Yearly kilowatts required, 365 days times 22 kilowatt hours will give us 8,030 kilowatt hours. Kilowatt hours produced per day. 7 daylight hours times 3.14 gives us 22 kilowatt hours. Watts produced in one panel, 1000 times 0.25 kilowatts equals 250 watts produced by one panel. What size system required? 0.25 kilowatts times 12.56 will give us 3.14. This is rounded up to 13 panels. This is where we're checking the installation price. Rounded up time frame of 2.15 years times the average yearly cost of $2,236. This will give us the installation price of $4,799. These two content descriptions show how the presentation is related to the curriculum. They provide details on student requirements and areas of mathematics that assist in both multiplication and division.